So you should be pretty familiar with derivatives at this point, how to calculate them and what they mean. And this video is going to teach stationary points and turning points, which are related to derivatives. You can use derivatives to calculate or find them. And first, let's talk about stationary points. A stationary point is any point on a graph of a function where the gradient function is equal to 0, or in other words, the tangent line is horizontal. So in these two graphs right here, one of y equals x squared and y equals x cubed, both of them have a stationary point at x equals 0, or the origin, because the gradient line or the tangent line is horizontal. And yeah, so that's a stationary point. It's where your derivative is 0. And a turning point is a type of stationary point. You can probably tell by the name, but it's where the graph turns directions. So even though both of these have a stationary point at the origin, only y equals x cubed has a turning point at the origin, because the graph changes directions in y equals x squared. It goes from going down, and then it hits the stationary point, starts going up, or positive, and that makes it a turning point. On the other hand, in y equals x cubed, it starts on the left side going up in the positive direction, hits the stationary point, and then still keeps going up. To make it a turning point, either this side will have to be going down like that, or this side will have to be going down. But since it just keeps going up, this is not a turning point, but it's still a stationary point. And to find stationary points, all you need to do is just take the derivative of your function and set it equal to 0. So for example, let's do y equals x squared, and dy over dx is equal to 2x, and set this equal to 0. And then our only solution is x equals 0, which you can see on the graph right there. And if the question asks you for the y value, or the coordinates of the stationary point, you simply plug in your x value back into the original equation and find your y value. And then you can do the same thing for y equals x cubed. Take the derivative, which is dy over dx, which is 3x squared, set it equal to 0. X squared equals 0, which means x equals 0. Again, that matches up what we have on the graph. And if the question asks you to find the coordinates, you plug in 0 into your x cubed, and then find the y value, which is 0. So yeah, your turning points are also always going to be your local minimum or maximum points, or your extrema. And I'm going to do an example to show you how to find all the stationary points and turning points of a function, and if the turning points are minimum or maximum, and how to find all the coordinates. So just everything basically. So if you have this function f of x equals 2x to the 4th minus 8x cubed, to find our stationary points, as I said, you take your derivative and set it equal to 0, and this one will be 8x cubed minus 24x squared, set it to 0, you can factor out the 8x squared times x minus 3, you get x equals 0 or 3. So now that's pretty simple, and you just have your x values of all your stationary points. And to find your turning points and to see if they're minimum or maximum points, you can do two methods, and I'll link both in the description, one for the extreme value theorem and one for the second derivative test. And I'd recommend watching the extreme value theorem first if you're not familiar with either of those. But the second derivative test is the easier method in my opinion, so I'll explain that first. So you simply take the second derivative. In this case, it's going to be 24x squared minus 48x, and you're going to analyze the concavity of the function at the point. So for example, if you have something that's concave up, something that's concave down, and the one that's concave up, your stationary point is going to be a minimum, and the one that's concave down, your stationary point is going to be something that's a maximum. And when your function is concave up, your second derivative will be positive because the slope is increasing, and when it's concave down, your second derivative is going to be negative because the slope is decreasing. So basically, if f double prime of x is positive, it's going to be a minimum turning point, and if it's negative, it's going to be a maximum turning point. So let's try this with the two x values that we found. For 0, we just have 0 minus 0, which is 0. And if you get 0, then you have to use the other method, which I'll explain in a bit. And you can't use the second derivative test. But let's try 3. So f double prime of 3 is equal to 24 times 9 minus 48 times 3. And this is going to be positive. You don't really have to calculate the actual value, because if you know it's positive, then that means it's concave up, which means it's a minimum. So our turning points, a minimum, it's going to be 3 comma something, and to find the y value of the point, we just plug in 3 to the original function. So 2 times 3 to the 4th is 162, 8 times 3 cubed is 216, and this gives you negative 54. So the y value at 3 is negative 54. And now let's find the nature at x equals 0. So like I said, you can't use the second derivative test. So what you're going to have to do is analyze the graph on both sides of x equals 0. So you find what the value of f prime of x is slightly before 0 and slightly after 0. Because let's imagine that you have a graph that's like this. Before you reach this point, if it's going down and you hit the point, then it goes up, then this means the derivative changes signs from negative to positive, and that means you have a turning point. And same thing, if you have something like this, the derivative goes from positive to negative, meaning you have a turning point. And if it's not a turning point, it goes from negative to negative or positive to positive. So if the derivative has the same sign before and after the point, then it's not a turning point. But if it changes, then it is a turning point, and you can figure out if it's a maximum or minimum from that. So let's try just f prime of negative 1, so before 0, and make sure you don't cross any of the other turning points. Like, don't try f prime of 4 for the other side. So f prime of negative 1 is equal to negative 8 minus 24, which is negative. And f prime of 1, let's try that. It's going to be 8 minus 24, which is also negative. So the derivative does not change signs, meaning that it just keeps going down even when it hits the stationary point. So a stationary point is just going to be 0 comma something, and to find that value, you plug in 0 to here, and it's just going to be 0. So now we found out everything. Our two stationary points are at 0 and 3, and at 3 is a turning point, a local minimum with a y value negative 54, and at 0 is just a stationary point with y value 0. And that's how you find everything. Now let's do a practice problem, and if you think you know how to do this one, pause the video and try it. This one says find the coordinates and nature of any stationary points on f of x equals 2x cubed minus 3x squared minus 36x plus 25. And as always, to find your stationary points, we take the first derivative, f prime of x, and this will be 6x squared minus 6x minus 36, and set it equal to 0. We can factor out a 6 out of all these terms, so this turns into x squared minus x minus 6 equals 0. You can factor this out pretty easily, and you get x equals negative 2 or 3. And now we have our x values for the stationary points, and to see if these are turning points, maximum or minimum, first we can do the second derivative test. If those don't work, we can do the thing where you take values slightly before the number and slightly after the number to see the behavior. But first, let's take the second derivative. So f double prime of x will be 12x minus 6. First, let's try negative 2. So f double prime negative 2 is equal to negative 24 minus 6, which is negative. And if it's negative, that means it's concave down because the slope is decreasing, which means we have a maximum. So, turning points. First one is at -2, comma something. And to find the y value, you plug in -2 into here, which is 2 times -2 cubed minus 3 times -2 squared minus 36 times -2 plus 25. If you do the math, you get 69. So the y value at -2 is 69, and it is a maximum. And now let's try f double prime of 3. And this is going to be 12 times 3 minus 6, which is positive. Which means, again, because this is a concave up, and it's going to be a minimum point. So at 3, we need to find the y value as well. We can just do f of 3, which is 2 times 3 cubed minus 3 times 3 squared minus 36 times 3 plus 25. If you do the math for this one again, you get -56. So that means our y value at 3 is -56. And because we figured out that the second derivative at 3 is positive, that means it's concave up, which means that we have a minimum at 3. And so, yeah, that's our answer. We figured out that both stationary points are turning points, figured out the coordinates, and whether they are maximum or minimum points. So, everything that I explained in this video, and all the problems that I went through, should give you a good introduction on stationary and turning points and how to find them, and everything about them. And if you're still confused on the second derivative test or the other method I explained, watch the videos in the description because they explain everything in more detail and give you more practice for them. But if you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.